today we are in section 2. And we are doing, let's see, hold on. This is our last section for this unit. It does mean test, but I do have several things I want us to do as far as like we've learned all the pieces, but I really want to put a lot of it together. So I don't think that we will test this week. It will probably be next Monday or Tuesday, maybe next week, I'm thinking. So we are doing derivatives. Of tangent, cotangent, secant, and cosecant. Alright, and our first example is going to be find the derivative of tangent of x. Okay, I'm going to remind you of one thing, and then I'm going to see if you guys can find the derivative of tangent of x on your own. Okay, and I'm going to remind you of this. Tangent equals sine x over cosine x. So now I want you to see, knowing the quotient rule that you now know, if you can find the derivative of tangent x. Right, so go ahead. Okay, so as I was walking around, it looks like most of you got to this here. So you're just doing cosine times the derivative of sine, which is cosine, minus sine times the derivative of cosine, which is negative sine. That gives you cosine squared plus sine squared, and that equals 1. So 1 over cosine squared x is secant squared x. Okay. So the good news is that now that you've done this once, you don't ever really have to do it again, as long as you remember that the derivative of tangent x equals secant squared x. Oh, that's a bad box there. So as long as you memorize that, you don't ever have to do it again. If you do forget it, and you're on a test or a quiz or something, you could do this all over again and get secant squared x. It's going to be a lot quicker if you have it memorized there. So, what I would like for us to do now is, I'm going to split you guys up. So, for example 2, I'm going to have, let's see, I'm going to have u3 right here, do the derivative of cotangent of x. For example 3, I'm going to have, let's see, how about Kelly and Lakin and Cameron, you guys find the derivative of secant x, and the example for Hannah and Wendy and Justice, I want you guys to find the derivative of cosecant x. Okay, so let's put these on the whiteboards. Okay, so if you'll find your spot with your people, you can erase the stuff we had. Do these on the whiteboards. I'm going to do them up here so that Liliana can see. Try to write it so that you don't have to practice. Try to write your answers so that you do not have a fraction when you get to the very end. You cannot do what you did right there. No, you cannot cancel those cosines because you have a minus on the bottom. But you're okay. That last line you've got right there is okay. But you can think of sine squared x is sine x times sine x. So one of those sine x's can go with the cosine, which will be cosine over sine. And then the other one will just be a sine x in the bottom, which is like 1 over sine. It is, isn't it? Okay, so we've got our three different examples up. And so if we look at example 2 back there, for your notes, we'll just, you don't have to do the whole thing, but for the notes, whenever you have cotangent, you're going to end up with negative sine squared x minus cosine squared x over sine squared x. Very similar to what we had for tangent, right? So you factor that out. So what you really need to write down for this, you don't have to write the whole thing. We just want to know the derivative of cotangent x equals negative cosecant squared x. And I just want on the, so you don't have to have all of that, written out. I just want you to make sure in your notes somewhere you've got the derivative of cotangent. For the derivative of secant and cosecant, you're going to do the same thing. Derivative of 1 is 0, so this part goes away. You end up with sine x over cosine squared x. So cosine squared x is like having cosine x and cosine x. So what you're doing here is sine x over cosine x. That is tangent x. And we could put a 1 right here, because we could multiply by 1. And that 1 over cosine x, that's secant x. And something similar happens over here with example 4. So we need to make sure we've got down our rules here. So our derivative of secant x is tangent x secant x. And our derivative of cosecant x is negative cotangent x cosecant x. So that gives us our derivative rules for all of our trig functions. Now, we already had sine and cosine, but to that we can add these 4. So, any questions on that part? It's in your very best interest to go ahead and memorize these 4 so that you don't have to know them otherwise and have to figure this out whenever you're doing more complicated problems, because you're going to see problems that look like this. For example, so we're on example 5. You're going to see problems that look like, let's see, where is that? Well, we might see something like f of x equals cosecant x over x, and ask us to find f prime of x. So if we're doing this problem, we could change cosecant to 1 over sine, but the fastest way to do this problem is just to use the quotient rule. So if we're going to use the quotient rule, we would have x times the derivative of cosecant x, which we just found was negative cotangent x cosecant x minus cosecant x times the derivative of the bottom, which is 1, all over x squared. Let me look real quick. And so, let me look really quick and see what the book gives the answers to problems like this for. Okay, so then we have cosecant in both of these right here. So we could factor that out. So you'll probably see it written like this. Cosecant of x times negative x cotangent x minus 1 all over x squared. They actually probably might factor that negative out. They'll probably do it this way. Negative cosecant x times x cotangent x plus 1 over x squared. They could go crazier with that. They could move that cosecant to the bottom, make it sine. They could try to get everything sine and cosine and change that cotangent. But it looks like, looking at the problem I was looking at that's similar, it looks like they don't do that in the book. They leave it pretty much like this. We also could have a problem that would look like this. We might have 1 f of x equals 1 over x plus e to the x tangent x, like this. Which I would go ahead here and write this as x to the negative 1 plus e to the x tangent x and so derivative of x to the negative 1 is just going to be negative x to the negative 2. What do I have to use to multiply e to the x times tangent x? Product rule. So then we would have e to the x times the derivative of tangent x, which we just found, and I'm sure you don't have memorized yet, but I know what it is. It's secant squared x plus tangent x times the derivative of e to the x. What is the derivative of e to the x? E to the x. So you're probably just going to see 1 over negative 1 over x squared plus, they'll probably just leave it e to the x secant squared x plus e to the x tangent x there. They might factor that e to the x out of these two, but since you can't factor it out of this one, probably not. Questions? You could try to change everything sine cosine, get common denominators. Maybe if they're really cool, they might do that sometimes, but usually not for those. So your homework. is again from page 154. This time you're going to have 45 through 48, 50, 51, and 53. This should be a pretty short assignment for you, so I'm going to tell you that I highly, highly, highly suggest that you try to do those free response questions tonight. We will go over one of them in class tomorrow. So it would be best if you knew which one was the most difficult for you, the one you had the most trouble with. You're also welcome to ask me questions. In the morning I think I have a meeting, but you can stay after today, tomorrow, come early Thursday if you have questions on those free response. Because we will have our first free response quiz on Friday. Oh, not Friday, Thursday.